Hey, and welcome to day three, the final day of our mini course. I'm Patrick Bentley. Again, thanks for joining me. Look, I wanted to recap the opportunity just one more time with you. We are going to be dropping in a few days our new course, Tech for the Rest of Us. This course is specifically designed for non technical entrepreneurs, non technical founders, non technical business people who want to understand the fundamental terms that we often use in technology when we're building applications. I truly think that in this day and age, it is vital, even if you're not going to be an engineer or the person who is actually going to be building a solution, to understand what are the components of a solution, what are the different decisions that can be made or that need to be made about that solution, and truly just understanding the jargon and some of the thought processes behind technology. And that's what this course is all about. This course is designed into bite-sized modules. We use a lot of different metaphors to help explain and make it easy to understand some of the things that you might be hearing on your job, some of the things that you might be hearing, whether if you're starting a tech company or if you're already working with a tech team. So what are you going to get out of this course? At the end of this course, you'll be able to understand technical terms, but more importantly, this is going to empower you to be a better leader inside of your organization. Now that you can, after taking this course, and you'll be able to truly understand some of those different concepts, this will allow you then to be able to talk to your team a little better, whether that's an offshore team, whether that is an internal team at your company or on your day-to-day job. But also, this will allow for you to have a better understanding of how to bring your vision to reality. So I just want to ask one more time, go ahead and sign up for the course if you have not. If you know someone who actually may benefit from this course, please send the link over to them. But yeah, let's jump into our third and final mini lesson of the day, where we're going to be talking about Retrieval-Augmented Generation. All right, so let's go ahead and jump into our mini lesson of the day. I'm really excited about this one. You've probably heard this term before, or if you haven't, then this is something that's going to be really, really useful for you to understand, especially in the wake of all of the new interest in large language models and in generative AI. But let's jump into our lesson for today. So let's start by just talking about what is RAG, right? It's an acronym. You've probably heard it before. You've probably seen some articles on LinkedIn or somewhere else if you've been following generative AI at all. But RAG just stands for Retrieval-Augmented Generation, right? And so what is RAG? RAG is basically a method of improving the content that's generated by essentially creating a large database or a data set and having the data retrieved in a specific context, right? So if you think about the way that LLMs work out of the box, right? If you've used Gemini, for example, it's trained on a certain amount of data, and then you're kind of working with what's already been trained. But there are a lot of situations where you may need that data to be really accurate, or it needs to pull data that's contextual, right? And so it's easier to do that with Retrieval-Augmented Generation. So ultimately what Retrieval-Augmented Generation does is it enhances accuracy, right? And it does so by using outside data sources. So that could be your own data sets. It could be copies of documents that you've written. It could be an FAQ document, for example, and customer support is a really good case study or good use case for this type of approach, right? But ultimately, what you're doing is you're enhancing the accuracy and the specificity of the results that you get from a large language model. So what are the benefits, right? So again, it becomes more accurate. The responses that you get from the LLM are going to be more accurate. They're going to be much more contextually relevant, and they're going to also be more detailed, right? So if you've ever interacted with the large language model, there's going to be usually the response is good, right? But if you're generating content, especially if that content is for your social media, or if it's for like some type of business use case, many times it may not have the voice, and it also may not have the specific context that it needs to. And so RAG offers a way for us to get more detailed and accurate results. So some of the use cases that this is very important for: customer service, retail, content creation, data analysis, right? So anywhere where that where accuracy is really important, right? So, but some of the things that we may not be thinking about are something like developer efficiency, as an example. So let's imagine that you're working in an enterprise, or let's imagine that you work with a development team and you need to onboard new developers, right? Well, something really cool that you could do is you could actually use RAG, you could use an LLM to create documentation to help onboard your developers quickly, more quickly to the sort of idiosyncratic or specific way that your team or your organization actually develops content. So develops software, right? So there's a lot of different use cases here. Think about customer service, chat bots, right? Like, so a customer comes to your website, you want to create a chat bot. Well, RAG is a really, really great tool that you could be using, or approach that you could be using, in order to make those result or answer the right questions within the right context. So how does RAG work? Well, if we're simplifying it, there are really just two phases of RAG, right? One is retrieval. So the AI will search through a data set, right? And it's trying to find the most relevant information specific to a query or the prompt, right? So let's say that is customer service. That could be past interactions, right? So you want to pull this customer's past interactions to get context around what their question is, or if they were served correctly. Or it could be, like we said, FAQ docs. It could be knowledge-based articles that you're using, how-to guides, in order to answer questions. So the first step is retrieval. The second step is then generation. So once the AI has retrieved that relevant information, then it uses that to generate a response, right? So this just makes sure that it's not only accurate, but it's actually the right answer for that context. Now, I do want to take a quick sort of detour here and talk briefly about how this actually happens. So you may have heard these terms being used before, right? If you get into RAG, you're going to hear about embeddings, and you're going to hear about vector databases. So I want to talk briefly about what those are. So if you have been coming to these mini courses, right, then you know we talked about on day one, what is a large language model? And ultimately, a large language model is really just an advanced deep neural network, right? It's a neural network. So neural networks don't really understand words. Computers don't really understand words, right? Like, they understand numbers, right? So we have to have a way for us to actually represent the text data as a number, right? And specifically as a vector, right? And we'll talk a little bit more about that. I don't want to get too crazy into that, but just understand that text needs to be turned into a number in order for a neural network, in order for AI to understand it. The way that we do that, or how we do that, is by using an embedding, right? So an embedding is what takes a text, or it takes some text and turns it into a numerical representation. That numerical representation is a vector. So it's important to understand that differentiation. So all embeddings are vectors, but not all vectors are embeddings. A vector is just a numerical representation of data. Embeddings specifically are a type of vector that can represent contextual or syntax meaning for text. Now, when we talk about these large data sets, and we want to turn those large data sets of text into an embedding, we have to have somewhere to store it. And so this is where vector databases come into play. So a vector database essentially is the database that manages and stores those embeddings that we create. So I want to quickly jump into, this is a TensorFlow embeddings projector. Now what this does is actually really cool, is it allows us to get a visual representation of words or vectors or more specifically embeddings, right? So we can take a set of words, and in this case, we're using the word to vec 10,000. It's built into the embedding projector, but it's essentially, 10,000 different words. But what I want you to understand is like why it's important to understand how the AI will sort of understand this text. So notice this this plane that we have here, or so this is the X and Y plane, right? So you're probably familiar enough with the X and Y plane, and then you see that that's the Z plane, right? So essentially what we have here is a coordinate space. If you remember pre-algebra in high school, then this will look familiar. But the important thing to understand here is that what the embeddings does, and there are different embedding models. The embedding basically allows for us to take these words, and in this case, we've got 10,000 words, and represent them in a coordinate space, right? And ideally, what happens is that as the neural network, the AI, the embedding is understanding these words, what will happen is that similar words will be kind of grouped in the same area. And so this is how a computer would go about understanding text and understanding the context and the meaning behind that text. So let's just randomly pick a word, right? And each of these points sort of represents a word, but let's randomly pick a word here. And let's go with look, right? So when we click on look, and again, I love this tool, it then will give us words that are similar to or syntactically similar, that live in the same vector space as that word. So let's take a look, right? So we've got some there, we've got look, but then there's looks, looking, looked, feel, find, appear. All of these words are very similar or syntactically similar. So this is how an AI would understand. So why is this important for you all? The technical details aren't really important as much as just making sure that you understand what we mean when we talk about embedding. So this is a visual representation of the embeddings of a 10,000 word set. So in a RAG architecture, right, like in order for us to implement RAG, we would have to take these embeddings and we would store it into a vector database. And that's what the embeddings and vector database thing is all about, right? So let's jump in. So what are some of the important things to remember about RAG? Well, one thing is like, why is it important to my business? There are a lot of different business applications. This is changing all the time. These are 3 of the most common implementations or uses for RAG. So of course, we've already talked about customer support. If you want to have a robust customer support system that's managed or ran by an AI, right, or at least implemented by an AI, that means that it needs to be context specific. You need to be able to understand what has the customer ordered, asked for before, how satisfied were they or not. If they're asking for how-tos, then we need to be able to go pull the answer from somewhere. So those are all really like organization specific things. RAG is really great for this. Content creation. So, again, like I'm working with LLMs to create content for me all the time, but sometimes it doesn't have my particular voice, especially when it comes to writing, right? So this is a really good way for you to utilize RAG, take some of your old articles, different things that you've written over time, and then you can have the AI mimic and be able to pull that data to generate content. And of course, summarizing large data sets and generating reports. So this becomes a lot easier for the AI and more accurate and more context specific for the AI if you can give it examples. So let's lastly jump into a quick sort of architecture, just so you can kind of wrap your head around what this looks like when we actually implement it. So let's say, for example, that we are using the customer service example, right? So we've got our large language model here. This could be, let's imagine that it's Gemini, you know. So we've got a set of documents, right? Those documents could include FAQs. It includes how-to articles that we've written on our support site or on our blog. It could also include different examples of answers or past chat histories, right? So we take all of those, and then we choose an embeddings model. So as I mentioned earlier, there are different embedding models, right? Depending on what you're trying to achieve. Some work better than other, but ultimately we have a different model. That model then is what we use to take these documents, and then we put those into a vector store. Now, in addition to that, now we've got it in a vector store. So when we actually query the LLM, number one, our query is also sent to that same embeddings model, right? So that our AI can understand what it is that's being asked of it, right? This could potentially go to the vector store, or it could be ephemeral, but you want to hold on to it. And then that becomes the vector store pulls whatever is relevant based on what it understands about the particular query. And then it sends that into a context query prompt. And then that is what actually goes to the LLM. So now the context query prompt not only holds the query, but it also holds any relevant data that has been pulled from the vector database as well, or the vector store. And then the LLM can then output, and what that output is going to be much better, way more accurate, way more contextually relevant than what you would see by just querying or prompting the LLM all on its own. So that is RAG in a nutshell, Retrieval-Augmented Generation. This is probably one of the most powerful concepts for you to understand as a business owner or a non-technical entrepreneur, is how this actually works, because this is going to be the key to truly unlocking the power of generative AI. So listen, thanks. I hope you enjoyed the sort of 3 mini courses. Please sign up for the course. There's more where that came from. Go ahead and hit the link here. Sign up for Tech for the Rest of Us. We will be opening the course up and sending out links for access to the course within the next couple of days. I'm looking forward to hearing from you all and getting your feedback about the course. And if you know anybody else who can benefit from something like this, please share it with them as well. If you or your company or anyone else is also looking to implement something like RAG, I also have a company. I am the founder of TechPeer. We're a consulting company, and we do this type of work for companies. So please reach out directly if you have any questions. Looking forward to seeing you all in the class. Thank you.